Hello, welcome to exercise testing example number 5. This one is a Submax test on the treadmill. So we've got a male runner. He's 35 years old, wants to have a program. So this is an actual test I did a few years ago. He wanted a program to help run the Cities of Surf. And so he's probably about 3 months out of there. And I said, well, he didn't want to do a max test, so I said, well, we'll just do a submax test, and that will give you quite a good load of data. So we did it on the treadmill in the lab, and we did 4 submax steady states at 8, 9, 10, and 11 kilometers per hour, 4 minutes each. So these are steady states running on a flat treadmill. Using we had heart rate, and we used ACSM equations to calculate the VO2. You can use Douglas bags if you have access to those or any other VO2 equipment. But in this case, we just did a quick test and used ACSM equations. This can be done anywhere in the gym, in the home. People have their own treadmills, and so it's a very simple, not very stressful test to do at all. But you can get quite a good piece of data out of it. Here we have the data of our treadmill runner doing a submax test. He weighs 75 kilos, he's 35 years of age, and his heart rate max is equal to 220 minus his age. That's his predicted heart rate max. You can use different formulas. I like to use the 220 minus age because it's easy to remember, but they're all around the same. So 185. Now remember, this is the biggest source of error in any submax test is the heart rate max. So just be aware of that. So his heart rate max could be 200 or it could be 160. We just don't know. But the data shows that he should be around that 185. And these are the 4 levels, 8, 9, 10, and 11. We need to calculate the VO2 for those levels. And the way we're going to calculate that is using our ACSM equation. We'll use this one because this is the one for the flat, 0.2 times speed in meters per minute plus 3.5. If it was on a gradient, you'd use this one because that has the gradient part of the equation. So we need to calculate meters per minute because that is our speed. So how do we do that? Well, it's simply, we know that this is kilometers per hour. We need to convert that to meters per minute. So we know that there are 1,000 meters in a kilometer, so times 1,000 divided by 60 minutes in 1 hour. So and that's 133 meters per minute. Fill that down, and that gives you the speeds in meters per minute. Now we calculate the VO2. So VO2 in mils per kilogram is, we just use that ACSM equation, 0.2 multiplied by the speed plus 3.5. There we go, 30 mils per kilo and up to 40 for 11 k's an hour. So once we've done that, we need to look at the determine what is the VO2 max speed. So if I just type in V, or just type in max, okay, this row here is going to be the max values. So in order to do that, we need to look at the heart rate speed relationship, and that means inserting a graph, a scatter plot graph, and we will add some data to that. The X value is going to be the running speed, submaximal running speed, and the Y value is the heart rates. Okay, and okay. There we go. So there's our relationship there. We'll look at what is the equation of that linear trend. So we'll add a linear trend line. So remember, different versions of Excel do it differently, but it's all there. It's all exactly the same. Same with Mac. More options because we want the equation. So display equation on chart and display the R squared as well. There we go. So that's our chart for our heart rate, which is Y, running speed, which is X. So what I might do is just calculate that slope, which is equal to slope. The known Y's is the heart rate, comma, known X's is the speed. And so that gives us that number which is on the chart here. The intercept equals intercept. Here we go. Known Y's is the heart rate, and X's, which is that one, 53.3. Good. So we need to calculate what is that maximum speed, or the speed where he will reach his max heart rate, and therefore by definition his VO2 max. So equals, so we need to rearrange this equation for X. Okay, so it's going to be the Y minus the intercept divided by the slope. So it's going to be the Y, which is in this case the heart rate, the max heart rate, which is 185, minus the intercept divided by the slope, 14.5. Okay, so once he reaches that speed, he's pretty well at VO2 max and his max heart rate. Okay, so what is the speed is that in meters per minute? And then the VO2, 51.7. And that's the max heart rate there. So this is all his max data on this row here. So his predicted VO2 max is 51.7 mils per kilogram. All right, so now that we know his VO2 max, we can then start to formulate his training program in terms of intensity levels. So as a percent of VO2 max. So VO2 max, and we'll start at say 40%, 45, and go up to 100. We could go faster than 100 for some super maximal efforts, but I'll just stick to the 100%, and we'll calculate his VO2 in mils per kilogram per minute. And we know that that's going to be 51, so it's just simply 40% of this number, 51.7. So there's the 40 divided by 100 to make it a fraction, times our percent VO2. So our VO2 max, I should say. And I'll put some dollar signs there because we're going to fill that column down. There we go. So at 40% VO2 max, his VO2 is 20 mils per kilogram per minute. And if I fill that down, that's his VO2 max down there, 51.7, and everything in between, every 5%. So at 80%, he's consuming 41.4 mils of oxygen per minute. Good, so now what we would need to do is calculate his speed. Speed at, in terms of kilometers per hour. And so we need to look at the relationship between his VO2 and speed. So in this case, we need to use the metabolic equations. So remember this equation up here, the VO2 is equal to 0.2 times the speed plus 3.5. We need to rearrange that equation in order to calculate the speed for each one of those VO2s. We know the VO2s, so we can sit that in there, but we don't know what that speed is. So if we rearrange that equation, and so it's going to be the VO2 in mils per kilo minus the 3.5. So 3.5 is essentially the resting VO2 divided by the slope, in this case it's 0.2. And obviously that's not kilometers per hour, okay? I'll just, that is in meters per minute. Per minute, there we go. And if we fill that down, we've got how fast he's going in each one of these intensity levels, 5% increments. And now we can calculate the speed in kilometers per hour. Okay, so it's going to be that number multiplied by 60 divided by 1,000. Okay, so equals the 86 meters per minute multiplied by 60 divided by 1,000 is 5 kilometers per hour. So it's barely, it's just that that's a fast walk at 40%. So he's not even really running. And then if we go down, there's our 14.5 at 100% VO2 max. So he really starts running at about 60% VO2 max. So he's not the fittest guy around. And so even just running at 8 k's an hour, he's sitting on 60% of his VO2 max. And so even sort of slow jogs, he's getting a pretty good training effect and adaptations at that intensity. So if we came back in a few months, just before the City to Surf, you would expect that this VO2 would be higher and this running velocity would be higher as well. So now he can go out training. You can set a training program. You can say, all right, I want you to exercise between, say, 60 and 70% of VO2 max. You need to run between 8 and 10 kilometers per hour. So you can do that by having a GPS watch, using your phone to see how fast you're running. There are a lot of apps that use those speeds. We can also use heart rate. So heart rate in beats per minute. And we've got this heart rate relationship here, and we know the speed. So this is speed down here. Then we can calculate what the heart rate is. So we just use this formula up here. Just substitute the speed, this column, for X, and that will give you Y, the heart rate. So equals our slope times the speed in kilometers per hour plus the intercept here. So 100 beats per minute. All right, we'll just round that up to full beat. Oops, sorry, I forgot my dollar signs. So our I, dollar sign and dollar sign. Always forget my dollar signs. There we go. So if I fill that down, great. So there's his max heart rate, 185, and these are all the heart rates in between. So if he's got a Fitbit, an Apple Watch, Samsung Gear, whatever, any device that measures heart rate, you can use that to set training zones. So again, if we wanted our 60 to 70% of VO2 max, exercise between 128 and 143 beats per minute. Stay within that zone and you'll be getting a fairly vigorous workout and pretty good physiological adaptations. So it comes down to the trainer as to how long he would exercise at, and you could just build that up, start at 10 minutes, go to 20 minutes, half an hour, excuse me, to an hour. So, excuse me. So by using heart rate, It's an easy way to set intensity, but you can also use speed as well with the with GPS. So there you have it. Doing a simple treadmill Submax test, you can get quite a lot of data and an individualized program that fits the person for the purpose that they need, in this case, to run the City to Surf. So a program can be designed around this data as a percent of VO2 max. But beware that this is a prediction. It's not an actual VO2 max. You really need to measure that, but it's the next best thing. And the predictions are quite good. There's probably about plus or minus 10% error in there, but it's still good enough to get some good training adaptations for your client.